So number 5 says a man standing 25 meters from a tower estimates the angle of elevation. Well, let me stop right there and start with my sketch here. So we have some person here, and they're looking up at some building. And what it says is that when they look up at the building, there's an angle of elevation. Oh, and there's a flagpole on top. There's a flag. Obviously, that's not really to scale, but just get the idea of a tall office building, and then on top of that building, there's a flagpole. And so what it says is that angles of elevation, and he's 25 meters away, right? So standing 25 from the tower. So we'll say this is 25. And then what we're saying he's looking up at the top. So the top and bottom of the flagpole. So here's to the top of the flagpole, and here's to the bottom of the flagpole. So there's really kind of two different angles going on there. So imagine, just imagine yourself. You're looking at something, and then as you look higher, of course, you have to tilt your head back, right? So that means there's a greater angle the higher up that you're looking. So that's what's happening here, is that he tilts his head back a little further to look at the top, and so that's where we get kind of that steeper angle that's going up to the top there. So, and what we're looking for, it says calculate the height of the flagpole. So what we really want to know here is that there's kind of two measurements. One measurement is we've got the whole building, right? So think of that as the total height. But so this is the total height. But we don't want to know the total height of the building plus the flagpole. We actually the only height that we care about is that we care about just this part of it. Just what's the height of the flagpole. Well, I could tell you what that is that if I knew the total height, and then what I would have to do is I'd have to subtract, so we'll say minus, this is just the building height, so this would be building height. So if I knew the total height minus the building height, right, so here's total minus the building, what's left over would give me just the flagpole. So it's kind of it's a two-parter here. So the total height, if we're talking about all the way up, is a 61-degree angle, right? Because the higher you're looking, the more you tilt your head back, that would be the bigger angle. And then the one where it says that we're looking at the bottom just would be 58. Now, this diagram within itself might be a little, kind of busy for you. So if you wanted to, we could, kind of rewrite this and separate it into really two triangles, which this could, and maybe I'll stick with my color coding here. So let's say that the blue here is going to represent the total height. So I'm going to actually have two triangles here. So I've got this one at 61 degrees, and he's 25 meters away. And then what we're looking for, we could call that x, right? So let's say this is the total height. And then we'd have a second. Let's maybe clear this out of the way. And then we're going to have a second triangle, which is just the building height. So this angle is going to be a little more acute, right? It's going to be less than the other. Distance is still 25. It's just we're not looking as high. So that would be 58. Right? So again, this is the total height. So this represents total, and this represents building. And then if we subtract those two things, so if we say total minus the building, that's going to give us the flagpole, the height of the flagpole. All right, well, let's get this thing labeled. So I've got, here's my angle, so that must be opposite. This is my 90-degree angle, so that must be the hypotenuse. And then this would have to be the adjacent. And then if I look at this one over here, kind of same idea. There's my hypotenuse. There's my opposite. And then this is my adjacent. And by the way, we should, similar to the last one, this is going to be a two-step problem, so maybe I could call that one Y. And so let me kind of pull out my menu here, my SOHCAHTOA. Let's see what we're going to use. So for my total height, I'm working with the opposite, because that's what I'm looking for. And I'm working with the adjacent, because that's what I know. So opposite and adjacent, O and A, that means tangent. Oh, and it actually works out here. I'm looking for opposite, and I know adjacent. So I'm actually going to use tangent for both of these. So for both of these, I'm going to use tangent. Only thing that's going to be different is the degrees. So this would be tangent of 61 degrees equals opposite over adjacent. And then this is going to be tangent of 58 degrees. And we'll say opposite over adjacent. So again, they're the same because the guy didn't change how far he's standing from the building. All he changed is how far he's tilting his head back. So, which is changing the degree. So we know in the variables on the top, the opposite to divide is to multiply. And so we'll do that to both sides. And we can kind of, since we're doing the same thing, we can kind of work both simultaneously at the same time. And then so let's rewrite. So I've got x equals 25 times tangent of 61. And this would give me y equals 25 times tangent of 58. So at this point, we'll throw that in the calculator. So I've got 25 times tangent of 61. And I get approximately 45.1. And then we've got 25 times, and just changing this slightly, 25 times tangent of 58, so we got approximately 40. We'll say approximately 40. So this number is bigger, and that should make sense because it represents the total height. So the total height is taller, minus the height for just the building, which is this height, and then the difference, right? The difference between the two, that would be my flagpole. So we're just going to subtract. So 45.1 minus 40, and so we get 5.1 meters. And so that would be our final answer there, 5.1 meters. So it's a two-stepper. Number 3 was a two-stepper where you added because we were looking for a total height. This one, it's a two-stepper we're subtracting because we actually know the total height. We're just wanting to know a smaller piece of it, so we're finding the difference.